Okay, we have a. Looks like we have a quorum now, so that's good. I'm looking up one little thing here. And then we're going to get rolling. I don't want to leave you astray. Before we begin, though, does anyone have any questions, guys? Talk to me.
Nope. Not at the moment.
Okay. If you do, speak up. One thing I wanted to point out. Let me just look it up in here. One thing I wanted to point out was, I don't think we did this, but do you see? We found G of B and H of C the other day, right? Right, guys? These are the marginals.
Yeah.
Do you see that these are in and of themselves valid PDFs, just like in the discrete case?
Mm-hmm.
It might not be totally apparent to you, but if you did a quick integration of G of B dB from 0 to 1, you'll see that it goes to 1. I actually did it before class myself and proved it to myself. Just make sure. If you do the same thing with H of C, which I did not do, but I am positive that you will end up with an integral that ends up going to 1. So they are, again, valid PDFs in and of themselves. Okay. Okay. Didn't we leave off needing to find the covariance? Sigma xy, yes, no?
I think so.
I think we solved for sigma B, but we didn't get to sigma C.
Oh, we didn't. My bad. There we go. We found sigma B. You're right. Okay. Are you guys ready to roll? We got a lot of work to do today. So you got to be lively, okay? Is that a deal?
All right.
We're not starting off on exactly the enthusiastic right foot here, are we? Sigma B is square root of 23 out of 20, yes, no?
Yep.
Yeah, that's what I got.
So we have to find sigma C, yes, no? Right, guys?
Right.
Okay, let's roll it, right? What can I get rid of? Talk to me.
I think you just need to keep that kind of scorecard on the right side.
I agree. We probably want to keep the... I actually clobbered the original function, so I probably need to write that back, don't I? But here's the marginal, so I think we need those. Do we need anything else? Can I get rid of this? And can I get rid of basically the left half of the board in blue?
You'll want to write down sigma B.
I did.
Oh, never mind. Okay, we're good.
So, can I clobber everything else, guys? Talk to me.
Yep.
Okay, going once, going twice. Okay, how do we find the standard deviation of the random variable C, guys? How do we do that?
First, we need to find the variance.
And how do we do that? A couple different ways.
For
right?
B, we use the expected value shortcut, where you subtract the mean squared.
I would strongly suggest we do the same, because it's going to lead to not a whole lot easier integral, but certainly easier, right?
A little less work.
Yeah, exactly, because we know what the mean is, right? So we just have to find the expected value of c squared, right? Minus mu sub c quantities, or squared, right? We know what mu sub c is. It's 8 out of 20. So what's the expected value of c squared?
What's the other option to find the variance? Okay.
And this, of course, ends up being 3 terms, right? When you multiply it out, it ends up being 3 terms that you have to integrate.
Yeah. This way we
So,
only, yeah, this definitely saves work.
yeah. Yep. Now that I erased it, does that make sense, everybody?
Makes sense to me.
Was that Brandon?
Yep, that's right.
Yeah, okay. We're almost done with the semester, and I finally recognize your voice. This is going a whole lot better than Digital Logic, I might add.
Well, doesn't Digital Logic have like 100-something people in it?
Well, there's I think there's 71 now of our best friends that are at main campus. Esteban and who else is in there? Kenny. Is Kenny online?
Yeah.
Okay. So Esteban and Kenny are used to me trying to guess. There's only like 2 or 3 guys at main campus that contribute really anything. And there's 4 girls. And Kenny and Estefan will attest that I have an incredibly hard time distinguishing the girls' voices. Like next to impossible. Next to impossible. Yes, no, right?
Yeah, I have the same problem. I don't want to talk.
Do ya? Yeah, but
Yeah.
I'm supposed to. I mean, I kind of pride myself on like knowing you guys. It's hard in the COVID thing, right? In the remote learning thing, it really is. But I mean, even with when we're in class, everybody's wearing a face mask, and I rarely see everybody's anyway. But I pride myself on knowing who you are by name when I see you, and online when I hear you. I know your significant others. I know who they are in general, and everything's blown out of the water. It really is. Okay, so how do we find the expected value of c squared? The expected value of anything is?
It's the anything times, would it be f of c?
H of c, right?
Yeah.
The marginal, right?
Yeah.
Because in terms of c, b doesn't exist, right?
Right.
Because we integrated it out. What are the bounds?
Wouldn't they be from 0 to 1?
Yeah, it certainly would be, right? Because again, b doesn't exist. Okay. So, don't forget minus mu sub c, right? We can plug in the number, can't we? We should probably maybe reduce it because we're going to square it. So 8/20 is equal to what? 2/5.
Yep.
So 2/5 squared is 4 out of 25. Okay. So let's go ahead and roll this bad boy and see what we get, right? We integrate this. Don't we get c to the integral is c to the 4th times 12 over 5. So that's going to be c to the 5th. Constant's going to be 12 over 25, right? Unless I screwed something up. And then c cubed becomes c to the 4th over times 6 out of 20, right? Let me know if I screw something up. C cubed. Don't forget to subtract the mean squared, okay? What does this go to, guys? Did I get this right?
I had 6 out of 15. Yeah, it's the same.
Okay, over here.
Yeah.
Everything else is right?
Yeah.
Okay, so it's negative 12 out of 25. If you plug 0 in for C, everything goes away, right?
Right.
This whole thing evaluates to 0. 6 out of 20. See, having things go from 0 to 1 is really nice when you're integrating, right? Okay. So we're going to subtract 29 25ths. This 2/5 is what? 8 out of 20?
Mm-hmm.
But we should have made it 10 out of 25, right? Did we screw something up, guys?
You got it right so far.
10 out of 25.
That was the same thing I have.
Well, I'm afraid we're going to end up with something negative. Did I say 29? No, it's 16 out of 25, right? We're going to subtract off.
Mm-hmm.
And this becomes what? Crud. All right. Easiest way to do this is make the common denominator 100. Well, in my book. Plus 30 plus convert this to 100. I think you get 40. Yeah. And convert this to 100 minus 16. What do you get? 64. Do you get 6 out of 100?
Yes.
Which equals 3 out of 50. That's the variance. Did everybody else get that number?
That's what I got.
Yeah.
Everybody? We good?
Mm-hmm.
So, are there any questions on how we got this number, guys? Any questions at all? This number implies that sigma C equals, square root of 3, square root of 3 over square root of 2, I think. Somebody make sure I'm right on that.
Yeah, that's what I had.
Okay. And if you don't like that, just make it, I don't know, square root of 3 over 5 radical 2.
Yeah, that's how I wrote it.
Okay. So square root of 3 over 5 square root of 2. Are there any questions on this, guys? I gotta clean up my office again. Any questions?
Nope.
I'm good.
Okay. Let's find the probabilities. Those are just double integrals, okay? And then we'll find the covariance and the correlation coefficient. I'll show you how to do that. Sound good?
Yes.
Ready to roll?
Yep.
We're gonna do D here, guys. Okay, we're gonna find the probabilities of certain things. Ready to go. How do we find the first one, guys? How do we find the Go on.
I think your board's trying to do the autofocus thing.
Because I forgot to fire up Logi.
Yeah, I was about to say.
My bad. All these software settings are wonderful, but don't you wish sometimes they just gave you a button?
Launch
You
them
know,
all
to
at
do-
once.
Yeah. Or to, turn this on, turn this off, autofocus, auto zoom, something like that. Or maybe turn autofocus on and off and 2 buttons for zoom in, zoom out. Those would make it a little bit easier if you're the only guy in the room. Okay.
You could always make it yourself.
Yeah, I could, I suppose. Yeah. Really not a camera guy, though. Okay. How do we find the probability that B is between those two numbers?
You integrate between those bounds, I believe.
What do we integrate?
The
The original function, right?
Is it the original function?
No.
It's g of b, right?
Yes, it most certainly is. Good job, Brian. It's G of B because we're not finding anything regarding C, so we need to use only the marginal of B, which again is in and of itself a PDF, a valid PDF. So the probability that 0.5 is less than or equal to B, less than or equal to 0.75. Yes, no? 7.3, right? 7.3, I think, right?
7.3. Yeah.
Probably should have made that 7.5 anyway. This equals the integral from 0.5 to 0.73 of G of B only. Okay? Right? Does that make sense, guys? So we'll go ahead and write the integral out. You're going to have to tell me what the numbers are when we plug them in. Because I can't calculate 0.73 raised to the third power off the top of my head. I can try, but I'd be wrong. Doesn't this go to b cubed over 5 negative b cubed over 5? This is going to be 3/5 of b squared negative. Oh, and these are all evaluated from 0.5 to 0.73. And then we have a plus 9.9 over 5, 9/5 of B. I can probably do that one in my head, but man, the rest of them, forget it. What do you get? And make sure I didn't screw anything up here. I probably did.
Shouldn't that first one be negative 3 over 15 b cubed?
But 3 over 15 is equal to 1 over 5, right?
Oh, okay.
The threes cancel. I didn't screw that up, did I?
No, you're right.
Okay. You guys should know me by now. You got to check my work that I do on the fly. Actually, you have to check all my work, whether I do it on the fly or not. Anyway. So this is going to be negative 1/5. And again, you guys are going to have to do the crunching, okay? Times 0.73 minus. Now I can raise 1/2 to the third power myself. That's 1/16, is it not?
1/2 to the third. That'd be 1/8.
Oh, 1/8, right? My bad. There, fixed it. Minus 3/5. Oh, and this is cubed, guys. This 7/3 is cubed. Like I said, I can't do that in my head. That's why I was wondering if we shouldn't change it to.
Oh, and it gives
Wait.
like gross decimals too.
Do you want to change it to 7/3 or 7/5?
If you want to.
Fine with me.
Make it a. What's that?
I said it's fine with me. I'm all for that.
Yeah, it's becoming rather cumbersome. I mean, yeah, if we're running this on a computer, or in Excel or on your calculator or something dumb like that, it make it much easier or a lot easier to keep it there. But we're doing this on the board and in your notes, so let's keep things a little on the simple side. So, guys, what's 3/4 raised to the third? Isn't it 9/64? Whatever that is.
No. 27.
My bad. 27. Yes, you're exactly right, Ryan. Thank you. I forgot to. I just squared the numerator. I didn't cube it. Minus 1/8. Guys, you can do this rather easily, right? This is 8/64, right? So you're going to get 19/64 in the parens. Isn't that correct?
Yes.
Mm-hmm. Minus 3/5. And then we're going to have 7 or 0.75 3/4 squared, which is 9/16, minus 1/2 squared, which is 1/4. Again, this isn't hard at all. We're going to get 5/16 out of this, aren't we? Inside the parens.
5/16, yeah.
And then we have 3/4 minus 1/2 times 9/15 times 9/5. 3/4 minus 1/2. Well, that's 1/4, obviously. So what do we end up with, guys? Plus 9/5 times 1/4. You can do a little magic, and well, that goes away, right? That's 9/20 minus 3/16 minus this. Somebody give me a number.
I got 13/64. 64.
I will buy that. I'll totally buy that, actually. Yep. Any questions on this? What was f of xy? Was it 2x plus 3y or 3x plus 2y?
2b plus 3c.
I'm
Is that what we're
sorry.
talking about?
2b plus 3c. Okay. So, guys, we just found the probability that B is between 1/2 and 3/4, right? Yes, no?
Yes.
Right? Now, I want you to think a minute, take a step back, just think about what's going on. We have determined that B plus C has to be less than 1, right? Or less than or equal to 1, right? Because these are fractions of ingredients. Remember that?
Yeah.
Right? So if, and what, B was chocolate bits and C was caramel, right? I think.
Cookie bits and caramel. Yes.
Okay, yeah. So if, who was working at the, was it Liam? He was working at the coffee stand.
Yeah.
So if Liam, if he's making somebody whatever it was, if he's making one of those weird things, right? If he puts in more cookie bits, right? B's going to tend to increase, right?
Yes.
hmm
What's going to happen to C? Is it also going to increase, or is it going to have a tendency, not a direct tendency, but in general, a tendency to go down?
Yeah.
Yeah, we'll go down.
It would. Do
Yeah.
you see that?
Yes.
Does everybody see that? In a mixture problem, something like this, if one goes up, the other has to go down because, again, the sum of them has to be less than or equal to 1. Okay?
And when one increases, it's taking up basically like the space that the other ones would have.
Exactly. Because whether it's by volume or by mass, the mass still works out, right? Okay?
Yeah.
So we have in these probabilities here between 1/2 and 3/4. Well, remember, there's actually 3 ingredients that add up to 1, right? There's B and there's C, and added what was it? The espresso, right? If you add all 3,
Yeah.
they exactly equal 1, right? So we're saying that out of the 3 ingredients, B can go all the way up to 3/4. Well, that only leaves 1/4 for the other 2 ingredients. Okay. So what does your gut say about this probability between 1/2 and 3/4, as opposed to the probability of something like 1/4 to 1/2? Same range, but just shifted. Do you think that probability would be more or less than this number?
It'd probably be more.
Do you see that? Another way you can look at it is, what's the mean value of B? It's 7 out of 20. Well, 0.5 is 10 out of 20. So this is well above the mean value. This range is well above the mean value of B. So the probability that we're going to land there is actually fairly small. It's like, like 20% or something like that if you do the math? Something like that?
Yeah, about 20.
Okay. So kind of a low probability, all right? Now, ready to do the next one?
Yes.
Okay, here we go. I got to erase this. Everybody okay with that?
Yeah. Do you want to change the bounds on the next one too?
Let me think a minute.
Both of those are
Yeah,
kind of
yeah, I
gross.
do. Can we make this 1/3 and this one 2/3?
Yeah. You got to change that 2 places.
Okay. Well, I can do that, right? 1/3 and 2/3, right? Where else do I have to change it?
Right above it on the board.
Oh, and here too.
Yeah.
This is okay. You're right. I missed that. I'm sorry. Okay, now we're good, right?
Yeah.
Okay, ready to find the probability that C is between 1/3 and 2/3?
Yes.
I got to erase the stuff in black. While I'm doing that, I want you to think about, is the probability that C is between 1/3 and 2/3, is that going to be like close to this number? Is it going to be way less than this number? Or is it going to be more than this number? And here's a very strong hint. Look at the mean of C. What's the mean of C, guys?
2/5.
2/5, right? Doesn't that fall not exactly in the middle, but kind of in the range between 1/3 and 2/3?
Yes.
So is this probability, granted it's a larger range, it's 1/3 of the entire range instead of 1/4, but it's 1/3. So is it going to be larger? Is this probability going to be larger? I'm sorry, this probability going to be larger or smaller than that number?
It should be larger.
Probably larger by a bunch.
Yeah.
I would think. Here we go, guys. By the way, does it matter if I include the equalities
No.
here? It most certainly does not. And I use h of c, do I not? Right?
Yes.
Negative 12/5 of c squared plus 6/5 of c plus 6/5 dc. That's our integrand. Integrate that. I'll do it up here. You do it on your papers, and we'll compare results. Okay. C4, so that's going to be negative 4/5 c cubed. Negative sign plus c squared, that's going to be 3/5. Plus 6/5 of c. Okay. Okay, that's what I'm going to integrate, guys.
That's what I got.
Okay, cool. So I get negative 4 times, 7/28 out of 5 times 27 plus, this is going to go to 1/3, so it's going to be 1/5. And this is going to be 2/5, right? Oh boy. So we got 3/5. Multiply that by, okay, so it's negative 28 plus 3 times 27 over 5 times 27. $81 minus 28. 81 minus 28. 53 out of 135?
Yep.
Well, that's isn't that fairly close to TUFES?
It's 39%.
Okay.
Yeah.
So this right here is 53. 53 out of 135. Are there any questions on how we got that number? And as we kind of sort of thought, right? This number here is, we figured it out, it's like pretty close to 20%. This number here is pretty close to 40%, give or take a percent. So yeah, this probability is twice what this one is. Okay? So that matches what we thought, which is a good thing. Okay? So those are 2 examples of finding areas under the curve, if you get back to your basic calculus. Now, how do we combine them? How do we find the probability that not only is B between the 2 bounds, but C is also between its 2 bounds? How do we do that?
Do we do a double integral on the original equation?
That's exactly what we do. Are you ready to roll? Yes, now.
Which bounds should be the inner or the outer?
You're going to have to tell me that. I'm just going to write it up here. I won't write the integral, but you're going to have to tell me which ones do you want to use for the inner and which ones do you want to use for the outer, okay? The integration might be a little bit simpler than what we've done here because I don't think we're going to get any variables raised to the, Okay, I'm going to erase this, guys. Here we go. I don't think we're going to have any variables. Well, we might. I don't know. Yeah, it might turn out to be kind of nasty. I'm not sure. Okay, probability that 0.5 is less than B, less than 3/4, comma, I'm just going to write it in fractions, guys. Okay, I'll spot you the double integral, okay? I'll even spot you the function we are integrating. Do we write dc dB or dB dc?
I think I want B to be the outer.
Okay.
Just because I like 1/2 more. I don't know.
I'll buy that. Does anyone have any problem with this? I guess if you do, you can integrate it the other way, and we should get the same answer, should we not?
Should, yeah.
Right? We better. So the bounds of C are 1/3 and 2/3, right?
Right.
What are the bounds of B?
1/2 and 3/4.
Okay. Here we go, guys. You do it on your paper, I'll do it up here. Okay. And I'll kind of sort of mumble along as I go.
I have
That's
a
how I
question.
saw it. Yeah.
Where do we get the 2b plus 2c from? Because I thought our equation was the 2b plus 3c.
Did I screw something up?
Yeah, it should be 3C.
I have absolutely no idea what you're talking about. All right. My bad. Okay. We're good now?
Yep.
All right. So we do the integral first. So that means we're integrating with respect to c. So b is a constant. B is a constant, so it's 2bc. With c going from 1/3 to c going to 2/3. Plus 3c squared over 2. Again, with c going from 1/3 to c going to 2/3. And this whole thing is still dB. All right, now, this goes to 3/2 of 4/9 minus 1/9. Right? So it's 3/2 of 1/3. Isn't that 2? No, 1/3, 1/3, 1/3. That's 1/2. This right here is 2b times 2/3 minus 1/3, which is 2b over 3. So this goes to 1/2 to 3/4. 2/3, 2b over 3, plus 1/2 dB. That's not so bad. Equals b squared over 3. 3/4 minus 1/2. Oh, what am I doing? That's not right. That's not right at all. Thought I could just plug it in, but not yet. Plus b over 2, 3/4. Still want to do that, don't I? 3/4 to 1/2. And this is going to equal 9/16, 1/3. 9/16 minus 1/4 plus 1/2 of this difference, which is 1/8. What do we get out of this? 5/16. Oh, yuck. Oh, yuck. Okay, what's this? 5/16 inside?
Yep.
Times 1/3 is 5/48 plus 1/8. What's this equal? That becomes 11/48. Anyone get that?
That's not what I got.
What did I screw up?
I have the same thing up until that last line.
So 5/48 plus 1/8. Did you get this? Did you get this?
That. Hold on, I'm not sure where you're different because I reduced it different.
Oh. There's a good chance I screwed something up, Brian. Three-quarters minus, this is 1/4. times 1/2.
Wait, 11. No, it's still different. Where did your 6/5 go?
Oh, did I drop a coefficient? I most certainly did. 6/5 multiplies the whole thing, doesn't it?
Yeah, you still get a different answer than what I got though.
Okay, so multiply this bad boy by 6/5.
That's what I have. 6/5 times that integral that you just circled. That's the same as what I have.
So what did I screw up? This is 9 out of 16. Square it. Bring the 1/3 out front, of course. But this is now 6/5 times that. Anyone else get anything, guys? Talk to me.
You know what? I think I'm the one that screwed up.
Oh, that's a change. Anyone else get this, guys? Multiply this by 6/5. God, it's so easy to drop a coefficient, isn't it? Six-fifths times 11/48. Did anyone come close to this?
What's your answer? 6/5.
I think it's going to be 11 out of 40. 11 out of 40?
That's what I got.
Any questions how we did this, guys? Talk to
Okay.
me.
I got 11 out of 40 once I fixed what I messed up.
Okay. So both of us messed up something different, it would appear. Or each of us messed up something different, I guess. Are there any questions how we did this, guys? Talk to me.
Nope.
Are we good?
Yep.
All right. Let's see what else. Okay, so does this number make sense? This is 11 out of 40, which is about 25%. So it's greater than this number, but that's because we're adding in this value. It's less than this because we are constraining it further by b. So that's why this number is between the two. Okay.
Interesting.
You guys ready to find covariance? Once I explain what it is? How are we doing on time? Oh, time's flying, isn't it? Okay, you ready to roll?
Yep.
Yep.
Can I get rid of the latest probability we found?
Yes.
Okay, so I'm going to erase the stuff in black here. Going once, twice. Okay, now, what does variance tell us?
The separation.
Okay.
That's
How spread
definitely
out
not
the
the
data
actual
is?
definition. Yeah.
No, it's not. But it kind of, in layman's terms or engineers' terms, the variance tell us how much spread there is in the data, right? So
Yeah.
it can tell us how closely compacted the data is, or vice versa, how spread out the data is, right? Well, covariance is kind of sort of something similar. But covariance gives an idea of the relationship between two random variables in a joint PDF. Okay. It gives us not only the negative or positive relationship, which we've already found out. We already theorized that the relationship would be negative, right? If one variable goes up, the other will have a tendency to go down, and vice versa, right? One goes up,
Right.
the other one goes down. Do you see that? That's what we think based on the statement of the problem, and I don't know, our instincts, our gut reaction, what we you step back and think about it for a minute. Okay. So he said it's probably going to be a negative relationship. There are other here's one. You have two here's one that many of us are familiar with, right? Let's say you have a Burger King and a Wendy's at a off ramp on the interstate, right? That's not uncommon, right? I'm going to avoid McDonald's because anyway. But let's say you got a Burger King and a Wendy's, right? Two somewhat similar fast food joints. Yes, no?
Mm-hmm.
Some of you prefer one or the other, right? Right. But if you didn't, and if people in general didn't prefer one or the other, okay, especially if it's if people are in a hurry, which if they're traveling the interstate, they kind of are, right? Anyway, what if X was the wait time at the Wendy's drive-through, and Y was the wait time at the Burger King drive-through? If for whatever reason X tended to increase, what did we say X was? The wait time at Wendy's? I don't know. If the wait time at one tended to increase, what would happen to the wait time at the other, do you think? Wouldn't it also increase?
Probably.
I mean, people wouldn't just keep piling into the line with the longest wait time, would they? The new arrivals in line, they wouldn't just keep piling. If Burger King's wait time is 10 minutes and Wendy's is 5 minutes because it's got fewer cars in it, aren't people going to gravitate towards Wendy's? The shorter line?
Makes sense. Yeah.
Again, everything else being equal.
Yeah.
Okay. So in that case, do you see it's a positive relationship? If X suddenly tends to go up, Y's gonna follow in general.
Like at
Okay.
lunch rush hour or something, everyone's going to start
Absolutely.
piling into both.
Right? And again, if you have no preference, you don't care. You're going to go to the one with the shorter line. Same is true at the grocery store. Yes, no?
Yeah. Always the shortest line you can find.
Right? Everything else is the same, right? The cashiers have the same speed. You don't have one line with 4 people with 2 items each and another line with 2 people of 250 items each, stuff like that, right?
Yeah.
If everything's the same, you're going to go to the shortest line. So that's a positive covariance. Do you see that?
Yes.
Does anyone not see that? Covariance can be positive, it can be negative. Okay? We also have the actual magnitude, which we call the strength of the relationship. Okay? If the covariance is either negative or positive, doesn't matter, but if it's incredibly close to zero, do you see that the two are pretty much independent? There's no relationship between the two. If one goes up, you can't tell anything about the other one. Okay? Do you see that?
Yes.
If the number's really big, we can usually, and there's, usually assume. Don't you love that phrase? Doesn't it just give you a warm fuzzy about everything being totally set in stone, right? We can usually assume, if the number is really big, we can usually assume that the relationship is fairly strong. Okay? If it's somewhere in the middle, then the relationship might be considered weak or not as strong, right? But here's the kicker. Right now, we don't know what weak, medium, and strong are. We don't know what the numbers are. And we're not going to know either. But right now, let's just find the covariance. Are you ready to roll?
Yes.
Now, covariance is given, well, covariance of x, y, and that's the way it's written. This equals the expected value of xy minus mu sub x, mu sub y. Okay? Well, here we have that mathematical expectation once again. We got it again. So we got a double integral to do again, and we got to subtract off a couple numbers. But guess what? We already have these numbers. We've already got them. And actually, what is sigma x, sigma y? Isn't it 14 out of 100?
Yes, it is.
And that's going to equal 7 out of 50, actually. Yes, no?
Yes.
So we just got to subtract 7 out of 50 out of the expected value of xy. Are you ready to find the expected value of xy? I hope so, because that's what we're going to do. Expected value of xy. You guys ready?
Yep.
Well, actually, we have BC, don't we?
Yeah, it's
Instead of xy. See, expected value of BC. What is it? Well, here, I'll write covariance of BC equals expected value of BC minus 7 out of 50. Okay? So we have to find this, right? What's the expected value of BC?
so it'd be the integral of BC times the original function.
So it's a double integral, isn't it?
Yes.
dB dC, dC dB.
Let's keep B on the outside, just to be consistent.
Okay, what are the bounds of C? I'll spot you the bounds of B. What are the bounds of C?
Are they both 0 to 1?
Nope.
It's 1 minus B. Oh, you already wrote it.
I did. Good
Okay.
job. Very good job. Okay. Are there any questions on the setup? Talk to me. Are we good? Yes, no. I'm going to go with yes. Okay. If you multiply this out, guys, and I think we should do that before we actually integrate. Okay. This is going to be 6/5 times 2b squared c plus 3 B's 3. I can't say it. BC squared. I think that's what you get. Yes, no? Pretty sure that's right.
Yeah.
So this is what we're going to integrate, guys. So you integrate with respect to C. With respect to C, B is a constant, okay? And notice, guys, that the product of the means I put out in front, okay? That way it doesn't get mixed up in the integral. And also, I think we have a lower likelihood of forgetting it because it's real easy to forget, as I'm sure you've already found. So we got 0 to 1, and we're going to integrate this with respect to C. So this becomes, I'm going to pull the 6/5 out. Yeah, I'll put the 6/5 out front. So this is going to be a 2 b squared c squared over 2. So it's going to be b squared c squared evaluated from c equals 0 to c equals 1 minus b. Okay, we're going to have a quadratic. That's not horrible. Plus, we're integrating with respect to c, so we have 3b c cubed over 3, so it's just bc cubed evaluated for c equals 0 to c equals 1 minus b. And this is all multiplied by dB. I don't think I've screwed anything up yet. I hope not. Oh, this can be nasty. This equals -7/50 plus 6/5. So this is going to be the integral of b squared times 1 minus b quantity squared. Oh, this is going to be nasty. Plus, you plug in 0 for c, everything goes away, okay? Plus b times 1 minus b raised to the 3rd power. And this is all, of course, dB. Okay, guys, did I screw anything up that you know of?
That's what I have.
Okay. Yes, it looks daunting, and to be honest with you, it is. But it might not be as bad as we think, okay? Multiply this out, this 1 minus b, okay? Yeah, b squared, 1 minus 2b plus b squared, which is going to go to b squared minus 2b cubed plus b raised to the 4th power. This goes to b times the quantity. You have to cube it, right? So that's going to be 1 minus 3b plus 3b squared minus b cubed. I think I did that right. B minus 3b squared plus 3b raised to the 3rd power minus b raised to the 4th. Did I do that right, guys?
I didn't do it right.
Oh boy.
Don't ask me how to fix it.
I think that's right. Somebody else help me out. And of course, we have to add these two bad boys together. But guess what? Terms are going to combine and terms are going to drop out too. Right? Hope you see that. If you add these two guys together, you end up with b right? That's handled. Now take care of the. Wait a minute. Did I screwed something up here, guys? This 2b here. This 2b right here. This should be 2b raised to the third power, not squared. Because it's 2b times b squared. Multiply those two guys together, you get minus 2b raised to the third power. I apologize for that. I screwed that up. So you add the squared terms together, you get minus 2b squared. Add the cubed terms together, you end up with plus b cubed. And the b to the fourth terms cancel out, don't they? B is the fourth minus, all right. Did anyone get this?
Yes.
As what we're going to integrate?
That's what I got.
Yep.
Okay. So, hearing two of you, I'm going to move on unless anybody has any questions. Always willing to entertain questions. So now we got to integrate this, right? I'll write it out so we don't skip steps. Okay, so when we integrate this, look, I didn't drop the 6/5 yet. Imagine that. B squared over 2, 0 to 1, minus 2b to the third over 3, 0 to 1, plus b to the fourth, right? Over 4. Well, this is going to go to 1/2. This is going to go to minus 2/3. This is going to go to 1/4. Okay, guys? So I get negative 7/5, 50ths. Let's see, if you do this math, you get 3/4 minus 2/3. If I'm not mistaken, this equals 1/12. I don't know why I wrote 13. It's 1/12. And multiply by 6/5. Don't forget that. So it's plus 6/5 times 1 out of 12. So I get negative 7/50 minus or plus 1/10. I think that's right.
I didn't get 1/12.
Out of this? Or did I screw something up in here?
No, you're right. Once you multiply in the 6/5, it should equal 1/10.
Yeah, this 1/12 is not multiplied by 6/5. Yeah.
Hold on.
Okay. So what do you get out of this guy? You multiply this, make it 50 out of, or 5 out of 50. So it's negative 7 over 50 plus 5 out of 50, which is negative 2 out of 50. That is the covariance. Okay? Positive or negative, guys? And what does it mean? Oh, this is, I forgot to show you. This is also written, the covariance is written sigma xy, my bad. That's the covariance of xy, okay? So do you see it's negative, right? It's negative 2 out of 50, right? Okay. So does that match what we thought? If B goes up, C should go down, and vice versa? Yes, no?
You said it's 2 out of 50?
Yeah, I got negative 2 out of 50. Is that the right answer? Is that what everybody else got?
That's
Yeah.
what I got.
Yeah, that's what I got.
We use a calculator. It reduces the negative 1 over 25.
Yeah,
Wait a minute,
Yeah.
what?
1 out of 25.
Oh, duh. My
But-
bad. You don't need a calculator for that. You just need a brain, which I clearly don't have. Yes, 1 out of 25. I apologize for not reducing it properly. I should have. Good catch, guys. What's that telling us, though? Big picture wise.
They have a negative relationship of that magnitude.
So does that match our initial gut that if B goes up, C goes down, and if C goes up, B goes down?
Yes.
It most certainly does, right? And based on this value, and considering that the values of B and C are between 0 and 1, what does your gut say? It's not an absolute number, guys. It's not. But what does your gut say about the strength of the relationship? This is 4%, by the way. 0.04. And B and C are, again, both range from 0 to 1. So is this a really super strong relationship, or is it kind of little on the weak side?
I think it's just right.
I would say it's a weaker relationship.
It's probably weaker, okay? One of the problems, gentlemen, is this. The answer to the question is, well, it's not strong, right? But it's not totally weak either, because it's not like 1,000th or something like that, or less than 1%. So it's somewhat weak, but probably more in the middle. But look at this, guys. What if B and C, instead of being, take a step back, what if B and C, instead of being fractions, what if they were percentages? Well, clearly f of x would have to change, but it would really be just a factor of 100, right? These would change by literally a factor of 100, right? The a would change, right? Because f of x would change. The mean value wouldn't be 7 out of 20. It would be 7 out of 20 times 100%, right? Right, guys?
Right.
Mu sub c wouldn't be 2/5. It'd be 2/5 times 100%, or instead of 0.4, it'd be 40%. Okay, everything makes perfect sense, right? It's just a scale factor. Do you see that?
Mm-hmm.
And these would be scaled up, right? The variance would be times 100. Standard deviation would actually be, because the square root would be times 10. These probabilities, if you converted the bounds instead of fractions, if you converted them to percentages, do you see that these probabilities would be totally identical?
Yeah.
Because the shape of the surface didn't change just because we changed the bounds. Okay? This would most certainly change, and it would be hard, and it's not as easy, shall we say. It's not as easy to make a direct connection because it's so heavily dependent upon units. Okay? That's why we have the correlation coefficient. Okay?
Wait,
Here's what
why wouldn't it change?
this will change, but it's more difficult to see how it changes, and more importantly, it's more difficult to interpret this because it's so dependent upon units. In other words, the scale, the bounds of the original function. So what we do is we use the correlation coefficient. Correlation coefficient is exactly what its name means or implies. Correlation coefficient gives us a better idea of the correlation between two random variables. And it's based on the covariance. Okay, ready to roll? Can I erase at least the top part here?
Yeah. We got a 3-minute warning, by the way.
Ah, just in time. Seems like class time just flies by. Correlation coefficient is written rho sub xy, and it equals sigma sub xy divided by sigma x sigma y. This takes the dependent upon units out of the picture entirely and gives us either a positive or a negative number based on the sign of this. And since we're dividing by the standard deviations of the individual random variables, it takes all the dependence of units out of the picture. Okay, so for us, we have rho BC equals the covariance divided by sigma B sigma C. I hope you see, and I hope it's obvious, sigma B, sigma C is the denominator is always going to be positive, right? Because the two sigmas are always positive. Okay. So this equals sigma. What's this covariance, which we just found at negative 1 out of 25. What are the two standard deviations we found? Square root of 23 out of 20 times square root of 3 divided by 5 radical 2. And oh boy. You guys are going to have to do your calculator thing on this. This is going to be 100 radical 2, which actually comes up top. This is square root of 23 times the square root of 3. I have no idea what you guys get. You guys are going to have to use your calculators on that. Sorry. This close to 5. This is going to be about 8-ish. 5 times 17, 85, 8.5, something like that. Do this. Well, I can do this. This is going to be negative 4 radical 2 divided by the square root of 69, which is very close to 8. What do you get? It's negative, I can tell you that.
I got negative 0.681.
So compared to 1, it's a little bit stronger. A little bit stronger. Not completely really dominant, okay? But it is stronger. There any questions? Oh, we're out of time by a minute. Are there any questions on this? Well, if you want, we'll handle another one of these with a different situation, so the bounds are going to change.
Wait, so
And
what does 0.681 mean?
This is a stronger relationship than we first thought. It's a stronger relationship than we first thought because you compare this to 1.
1 is the max,
Yeah.
plus or minus 1.
Yeah.
Okay.
Okay. And I hope that makes a little bit more sense because, we thought this was a kind of a weak relationship, might be weak to moderate, I guess. But it turns out that it's a little bit stronger than we thought. It's actually moderate. Okay. All right, we'll pick it up here, guys. Do you want to do another example of this on Thursday?
Yes, please.
Okay, we'll do another example of this on Thursday. And it'll be it won't be too bad. Also remind me on Thursday to go over conditional probability functions with joint distributions. So
Hey, there was
Go
homework
on.
today. Was due today. Was there another? Did you assign more problems? I didn't see any.
No, I have to do that though. They'll be in chapter. Tell you, we can do that now if you want. They'll be in chapter 4, guys. And where are we? So let's do yeah. Let's do 55. I want to find a good 55, 61. $65. Here we go. 67. Let me write that down. Does somebody remember what I said?
55, 61, 67. And I think you said chapter 4.
Chapter 4. $55.
61,
No,
67.
61, 65, and 67.
Oh, my bad.
No, you're right. You're right. Yeah. What did I say? 61, 65, and 67?
Correct.
Okay. I don't think it'll take you too long. But there's some expectation. Is there one? Why don't they have covariance in here? We just talked about it. Oh. Okay. Let me assign a couple more. $49 and $51, guys. They're in the previous section. Okay.
When's this due?
I don't know. When do you guys want to? You want to do it over Thanksgiving break, or sound good?
Yeah,
Do
that's
the,
fine.
do the Tuesday after Thanksgiving.
That'd be November 30th.
Sound good, guys?
Yeah.
Yep.
Okay. Have a wonderful week, guys. Stay safe. Stay healthy.
And you wanted us to remind you to do conditional probability functions with
With
What was
joint
it?
PDFs, yeah.
PDF.
Yep. We'll do a
Okay.
couple examples. Okay. Remind me to do that. I was going to get to it today, but obviously we don't have time.
I wrote it down.
Okay. And
Thanks.
we'll do the marathon runner example in case I forget which one we're going to do.
Okay.
All right. Take care, guys. Have fun.
Thank you.
Yep.
Have a nice day, Professor.
Have a good one.
You too.